Math 1314, section IC1, spring 2022, Tyler Junior College, section 1.5, linear inequalities, video 2, reversing the sign. Now, some of you may remember this, but when you're solving an inequality, there are certain scenarios that require you to take your inequality sign and reverse it, meaning if it was greater than, it becomes less than, and vice versa. So what is that scenario? Well, let's set up a problem and I'll show you. How about this problem? These are pretty easy to create. We're going to solve, let's solve a negative 2x plus 7 is greater than, let's make it less than, is less than 25. Okay. If this said equals, it would be pretty easy to solve. We would start by subtracting 7 from both sides and then dividing both sides by negative 2. But it's an inequality. However, that doesn't change what our first two moves are. We are going to try to isolate the x by getting rid of the numbers attached to it, starting with the plus 7. If I subtract 7 from both sides, that will cancel the 7s and leave me a negative 2x on the left, less than, and on the right, 25 minus 7 is 18. And now the move that we would do is to divide by negative 2. Well, the negative 2's would cancel on the left. That would leave the x. And on the right, 18 divided by negative 2 is negative 9. However, if I bring down the less than sign, that will actually be the wrong answer. And to convince you of that, I'm going to draw a really quick number line with a negative 9 on it. If our solution is x is less than negative 9, then that means we would shade in the left side of negative 9, parentheses on the negative 9 because it says less than, not less than or equal to. This means that any number to the left of negative 9 should make the original inequality true. Well, what's a number to the left of negative 9? How about negative 10? Well, if we're claiming this is our solution, negative 10 should make the original inequality true. So why don't we go check it? Let's substitute negative 10 for the x. And now our inequality reads negative 2 times negative 10 plus 7, let's move my head, is less than 25. Well, negative 2 times negative 10 is 20. Still got the plus 7 less than 25. And then 20 plus 7 is 27. Wait a minute. 27 is less than 25. No, it's not. Well, that means that negative 10 is not a solution, which means our number line was wrong, which means our inequality was wrong at the end. X is less than negative 9. Now, how'd that happen? And can we anticipate it and prevent this from happening? And the answer is yes. Because as some of you know, and I know some of you are watching this video saying, oh, I thought you were supposed to, you are correct. I was just showing you that if you don't know the move I'm about to remind you of, then things will go astray. I'm going to take it all the way back to the point where we divided by negative 2. We do get x on the left. We do get negative 9 on the right. However, and here's the rule I know that some of you were saying, if you multiply or divide both sides of an inequality by a negative number, I'm going to put a comma there and pause. We just did one of those moves. We just divided both sides of the inequality by a negative number. Then you reverse the inequality sign. In other words, let me see if I can format this a little bit better. I think it looks a little bit better. In other words, if you multiply both sides by a negative number or divide both sides by a negative number, you take the sign and point it the opposite direction. The way I normally try to represent this is to draw a squiggly little arrow emanating from the inequality symbol to indicate that I'm turning it around. Since it was originally less than, it is now greater than, which means our solution is actually x is greater than negative 9, not x is less than negative 9. If we were to draw the we have the inequality now. If we were to draw the number line, then it would be pretty straightforward. There's -9. We would shade to the right because it now says greater than. And we would still use a parentheses on the -9 because it is not equal to. So we have to exclude that. And the interval would be, let's see, our shaded part starts at -9, parentheses because it's not included, comma, infinity. Infinities always get parentheses. Give me 1 second to move some of this stuff around. I'm just going to take myself out of the picture because it's getting a little crowded down there and I want it to be easy to follow. All right, let's see if I can grab the entire number line here. Looks like I did. And here's our interval down here in the lower right-hand corner, parentheses, open parentheses, -9, comma, infinity, close parentheses. But again, this thing that I'm copying and moving to the next page is the whole lesson of this video. If you multiply or divide both sides of an inequality by a negative number, then you reverse the inequality sign. Let's take a look at another example because they're all pretty much run the same course. For example, let's say I ask you to solve 6 minus 3x over 5 is greater than or equal to -4. All right. 1 second, folks. I'm going to pause this video. I've got this dinging on my phone. All right. Oh, no, a fraction. Well, don't let it bother you because by now you should know that to get rid of a fraction, which is just a division problem, we're going to multiply both sides by the denominator. So let's start by multiplying both sides by 5. That will cancel the divided by 5 on the left. That will leave a 6 minus 3x on the left. On the right, we get -4 times 5, which is -20. Do we reverse the sign? The answer is no. Some people will want to reverse the sign because we just did a multiplication problem with a negative, -4 times 5. But that's not the action that causes the sign to turn around. I'm sitting here making hand gestures, forgetting that my video was off. Doing a multiplication problem with a negative number is not what causes the sign to turn around. What causes the sign to turn around is the action that you take on both sides. What we did to both sides was multiply by +5. That is not one of the actions that causes the sign to flip. So the sign is not flipped yet. We have that backward subtraction problem issue. And remember, when you have that, get rid of the number in front. And in this case, the number in front of the subtraction sign is the 6 here, by subtracting it from both sides. I know the opposite of subtraction is addition, but the 6 is positive, and so to make it cancel, we need to use a -6. We will subtract 6 from both sides, and let's see what that gives us. These 6's cancel on the left. We're left with -3x on the left, greater than or equal to -20 minus -6 is -27. Excuse me. It's -26. Let's move this to the top of the next page. -3x is greater than or equal to -26. And now what's our last move to get the x by itself? That would be to divide both sides by -3. Cancel the -3's on the left. That leaves an x. This is the move that invokes the sign flip. We divided both sides by negative, our sign is going to flip and become less than or equal to. Now, what can we do with this fraction over here? Well, numerically, not a thing. 26 will not divide by 3. It is not reducible, but the two negatives cancel because negative divided by negative is positive. So at the very minimum, you would be expected to write the answer as a positive, and 26 over 3 isn't something we can do with. Okay, what would the number line look like? Well, I know 26 over 3 is a fraction, improper at that, but it's the only number we're focusing on, so we can put it anywhere we want. The only time you have to be careful when putting things on a number line is when there is more than one number. Then the lesser numbers go to the left and the greater numbers go to the right. We have x is less than or equal to 26/3. So we need to shade to the left. If we shade to the left, oops, that's not what I meant to do. If we shade to the left, because it says less than, we'll be over here. And on the 26/3, we would need a bracket because it says less than or equal to. And I just ran right into the 26/3 on the bottom. Let's see if I can clean this up just a little bit. Oops, didn't mean to do that. Okay, it looks like I'm not going to be able to erase that without erasing that. So let's try this again. Let me start by drawing the arrow to the left and putting the bracket, the square bracket, on the 26/3 because it says less than or equal to, and then I'll just draw the 26/3 underneath that. So what would our interval be? Well, this goes all the way to the left, which is negative infinity. So our interval would be parentheses, negative infinity, comma, 26/3, and then a bracket because it said less than or equal to. So be very careful when you're solving a linear inequality. If you multiply both sides by a negative or divide both sides by a negative, it will cause your inequality sign to turn around.